This video is about the safety architecture behind useful AI coding agents. The important point is that safe code editing is not one feature. And it is not just ask before running a command. Serious tools, separate approvals, sandboxing, and review artifacts because those layers solve different problems. I want to make that concrete using the shared pattern you can see across modern coding agent CLIs. The product names differ, but the design pressure is the same. If a model can read files, edit code, run commands, and touch git state, you need a runtime that can decide what is allowed, what needs confirmation, where actions execute, and how changes stay reviewable afterward. The first mental shift is to stop grouping all AI assistants together. Answering a question about a file is not the same risk class as editing the file. Editing the file is not the same risk class as executing a command. And executing a command is not the same risk class as pushing code, calling an API, or deploying something. Once you see that ladder clearly, the rest of the safety architecture starts making sense. The runtime needs different controls at different heights of risk. If everything is treated like one generic tool call, the safety model becomes vague exactly where it needs to be explicit. This is the core model for the whole video. Policy, approvals, sandboxing, and review artifacts are not redundant words for the same thing. Policy decides what kinds of actions even belong in the allowed surface. Approval decides whether the human must confirm the next action now. The sandbox decides how much of the machine or workspace that action can actually reach. Then, after the action runs, diffs, logs, and test results make the outcome inspectable. If you collapse any of these into the others, you lose useful control. If you keep them separate, the system becomes easier to trust and easier to debug. Useful coding agents are loops, not single prompts. The user asks for something, the runtime assembles context, and the model decides what to do next. If the answer is a tool action instead of plain text, that request should not go straight to the machine. It should pass through a policy layer, then an approval layer, if required, then an execution layer with explicit boundaries. The resulting diff, command output, and test output come back into the next turn as machine-readable evidence. That is the part many product demos skip, but it is the part that makes safe automation possible. Approvals exist to control timing. The important question is not only whether an action is allowed in principle, the question is whether the runtime needs the human to approve this specific step before it happens. In a new or sensitive repo, you may want reads to pass automatically, but file edits and shell execution to pause. In a trusted repo, you may allow ordinary workspace edits, but still require confirmation for network access. Commands outside the workspace, or anything that could touch credentials and external systems. That is a much more useful framing than one giant safe mode checkbox. Sandboxes solve a different problem than approvals. A command can be approved and still be badly contained, or it can be denied even though the sandbox is strong. Sandboxing answers where the command runs and what it can reach. Does it have write access only inside the workspace? Does it have network access? Can it touch sibling directories? Can it run package managers that modify the wider environment? Those are concrete engineering boundaries. Without them, a coding agent is effectively just a remote control layer for your machine. Is not the same thing as a disciplined repo assistant. This is the most underrated layer. Humans do not build trust from the approval dialog alone. They build trust by reviewing the resulting patch, the changed files, the test output, and the command trace. That is why diffs are such an important part of coding agent safety. A good agent should not just ask permission and then disappear into a black box. It should come back with reviewable artifacts. The best safety loop is not trust the model. It is trust the model enough to inspect exactly what it changed and verify the result with ordinary engineering tools. This is what a disciplined coding agent interaction should feel like. First, the tool inspects the repo and narrows context. Then it proposes a plan, or at least an explicit next step. Before risky work, it asks for approval. When approved, it executes inside a constrained environment, then it returns with a patch and verification evidence. The human can review, refine, or stop. That loop preserves automation, but keeps the human at the control points that matter. It also produces artifacts that fit normal software workflow, means the agent is helping inside engineering, rather than inventing a separate, invisible process. I do not want to turn this into a product ranking slide. The important point is structural. Modern AI coding tools keep arriving at the same separation of concerns. One layer defines what the tool can try to do. Another decides when the human must approve. Another constrains where the action executes. Then, the system relies on ordinary review surfaces like terminal output, patches, and tests. The exact terms vary across Codex, Claude Code, and Gemini CLI. But if you strip away naming, the design pattern keeps repeating. It is the practical answer to the same underlying risk model. One of the biggest mistakes is treating trust like a binary switch. Either the agent is fully boxed in and useless, or it gets broad control immediately. A better model is a trust ramp. Start with inspection, then allow narrow repo edits, then allow routine commands inside the workspace. Keep stronger controls on network calls, secret handling, system package installation, or actions outside the project boundary. That creates a learning path for both the human and the runtime. The agent earns trust through small, correct, reviewable changes instead of one dramatic leap of faith. This is where trust breaks. If the system has no clear approval boundary, the user gets surprising side effects. If it has no sandbox boundary, an innocent-seeming command can reach places the user never intended. If the patch is huge and messy, review becomes symbolic instead of real. And if the runtime exposes too much capability by default, the model spends its time choosing from tools it never should have had. None of those failure modes are really about prompt quality. They are control plane problems, and they need control plane fixes. If you're building a coding agent, the main lesson is that safety is not a prose guideline. It is runtime design. Approval rules should be explicit data, not vague prompt text. Sandbox boundaries should be real operational controls, not merely descriptive labels. Artifacts should be first class outputs, not accidental leftovers. And blocked actions should explain whether the problem was policy, approval, sandbox scope, or runtime failure. That clarity matters for users, but it also matters for the agent itself. A system that can explain why something was blocked is easier to steer and easier to trust. The takeaway is simple. The goal is not to make the agent harmless by making it incapable. And it is not to make it powerful by hiding the control surface. The goal is bounded autonomy. Let the tool do real work, but keep the boundaries clear. Separate policy from approvals. Separate approvals from sandboxing. Separate execution from review. And keep diffs, logs, and tests central to the experience. That is how AI coding agents can edit code safely without turning safe use into a ceremony nobody will actually keep following.